Okay, let's see partial fractions now case by case, and here we'll discuss the first scenario or first case. Before that, a quick revision or a quick definition of improper fraction again. We know that improper fractions are the fractions where numerator is bigger than the denominator, for example. In algebraic term where px and qx are two polynomials, then the fraction will be improper when degree of px is greater than or equal to the degree of qx. I'm sure you know about the degree of any polynomial. The degree of any polynomial is the greatest or highest power of variable in that polynomial. Look at the example here. 6x cubed minus 2x plus 1. So the highest power of x here is 3. So the degree here is 3 in the denominator, and the degree of numerator, and the degree of denominator is 2. So because the degree of numerator is bigger than the degree of denominator, therefore this is an improper algebraic fraction. Similarly, here you can see the degree of numerator is 3 and degree of denominator is 1. So this is also an example of improper fraction. Now coming back to our actual discussion, case 1 of performing partial fraction. So partial fraction when the denominator has distinct linear factors. So in general, we can say that px plus q divided by ax plus b into cx plus d. So these are the two distinct linear factors in the denominator. So this the partial fraction of this type of expression can be then written as is equal to, we define two variable a and b, capital A and B, just to distinguish them from other variables. So a over first factor plus b over second factor. Okay, you know that partial fraction is writing down this sort of expression back to that back to the original function. So if we extend this one to three factors, px plus q over ax plus b into cx plus d into ex plus f, so we need to define three variables here, a, b, and c. So a over first factor plus b over second factor plus c over third factor. Similarly, you can extend it to 4 as well. So let's have a look into the example here. Express 2x minus 13 in partial fraction. So this is the first case, and you can see that there are, in the denominator, there are two linear functions which are distinct or different from each other. So we can start writing a 2x minus 3 over 2x plus 1 into x minus 3 is equal to defining variable a over 2x plus 1 and plus defining variable b over second factor. Okay, then in the next step, multiplying out each and every term by this. So what will happen then? 2x minus 13 multiplied by 2x plus 1 x minus 3 over 2x plus 1 x minus 3. Okay, so of course this will cancel by that, is equal to a over 2x plus 1 into 2x plus 1 into x minus 3 plus b over x minus 3, 2x plus 1 and x minus 3. So clearly 2x plus 1, 2x plus 1 cancels, x minus 3, x minus 3 will cancel out. So we're left with 2x minus 13 is equal to a into x minus 3 plus b into 2x plus 1. So let's say this is our equation 1. So I've just performed these steps. It is easy to understand anyhow. You know all these procedures. So now we have two terms in the denominator here. One is x minus 3. If we say x minus 3 is equal to 0, so we'll get x is equal to 3. And insert this value of x in equation 1, we will get the value of b, which is minus 1. Okay, you can check this one. Now the other denominator is 2x plus 1. So let's say 2x plus 1 is equal to 0, which gives you x is equal to minus 1 over 2. And inserting this value of x in equation number 1 here, you will get the value of other variable a, which will give us an answer equal to 4. Therefore, our answer or partial fraction for 2x minus 13 over 2x plus 1 x minus 3 is equal to value of a is 4 over 2x plus 1, and value of b is negative 1, so negative into this positive is negative 1 over x minus 3. So that is our answer. You can check it by solving this part again, and you'll see that you'll get back this fraction. So this is a method in which we use the values of x from the denominator in our equation to get the unknown values of these two variables a and b. There is another method also in solving these sort of expression, and that method is basically involve equating the coefficients. So again, if we look into this part, we can say method 2 here. Okay, 2x minus 13 is equal to a x minus 3 plus b 2x plus 1. So expand or open the bracket, 2x minus 13, this will give you ax minus 3a plus 2bx plus b, and then collect the like term, ax and 2bx, and this is without x minus 3a plus b. And here you can see that x can be taken as a common factor, and you will get a plus 2b, and here you will get minus, if you take minus 1 as a common factor, so you'll get, I just leave it as it is, you will get here minus 3a plus b, so 2x minus 13. Now equating the coefficient means that equate the coefficients of x, so we get 2 is equal to a plus 2b, and equating the coefficient of where there is no x, so minus 13 is equal to minus 3a plus b. So clearly you can see that you get two equations, and if you solve these equations simultaneously, you will again get a is equal to 4 and b is equal to minus 1, and therefore the answer is again 2x minus 13 over 2x plus 1 x minus 3 is equal to 4 over 2x plus 1 minus 1 over x minus 3. So this is how you can perform the partial fraction of first types of expression in which the denominator is a linear function and both of the factors are distinct from each other.